from the mycelial mats, they start to form pinheads, which are little baby tiny mushrooms. And the mushroom that you see above the ground is the reproductive part. It's only about 10% of the actual mushroom, or even less sometimes. So from these pinheads, it grows and forms what you can actually see above ground, the actual mushroom. Oh, I have an awesome video of it works. Oops. Alright, I can show you guys afterwards, but basically this whole process happens really quickly. When the mushrooms decide that they want a fruit, it takes about 10 days from the tiny pinhead formation to the releasing of the spores. And I guess we should backtrack a little bit and talk about why mushrooms are actually really cool. As you guys know, they play a really important role in the ecosystem. They act as the grand decomposers of all the nutrients and the recyclers. So when something dies, they basically excrete enzymes from their cells and then reabsorb the nutrients and basically work to complete the entire life cycle. Other than that, they're delicious. And they have some really other interesting properties that researchers are just finding out about, one of which is their ability to break down lots of toxins, including hydrocarbons from oil spills, PCBs, dioxins, and a whole grand slew of really toxic chemicals. So that's one area of research that's rapidly evolving right now. And then another area is their benefits to the human immune system. So basically there's a whole new line of supplements coming out from freeze-dried mushrooms, and they found that they're helpful with such things as breast cancer, tumor prevention, people who have liver and kidney problems. And if I'm not really going to talk about that too much today, but if you're more interested, I have a book with mycomedicinals. It's called Mycomedicinals, and it has lots of research articles that have been released recently about the benefits to human health. So feel free to come up afterward and check that out if you want. Oh, and by the way, all these books are for sale, so if you want to come look at them and inspect afterward, you're more than welcome to. They're sold at a discounted price. So just talking about that. All right. So now you know about the life cycle of mushroom. Does anyone have any questions about that? Okay. All right. So moving on. Now I'm basically just going to talk about mushroom propagation and what it takes. In Colorado, it's a little bit trickier than in any other place, really, because it's so dry here, and it takes a fair amount of humidity to grow mushrooms. So in other places, you can use really low-tech methods that are really easy, but here's a little more tricky. So I might touch on both a little bit, but I think I'm primarily going to focus on what it takes to cultivate mushrooms here in Colorado. Okay, so as you guys know, the mushroom life cycle starts with spores. So you can either start with spores, or you can actually take a clone of a mushroom that already exists to propagate more mushrooms. So the way that you would start with spores is basically you take a fresh mushroom, like one of these, cut off the stem, and it helps to get one that's really fresh. The ones from the grocery store, you'll probably want to do the second method, which I'm going to tell you about in a bit. But if you find a very fresh mushroom, what you do is you take a spore print, and it's very easy. You just put it on a piece of paper, put a glass over it, and let it sit there for overnight. Remove that, and you should see a ring of spores. So, something like this. Kind of mimicking what it looks like on the underside of the gills. Or the second way, which I think is actually really, really cool, is you can take a clone of a mushroom that already exists, something like this. What you do is you cut the mushroom in half. And I should probably draw this up on the board. And then, as you can see, it's kind of like a little half moon type thing. And what you do is you take a little piece of tissue from this area right here, because that's the newest growth, so it's got the freshest and most robust DNA. You take a little tissue, and you basically put it on a Petri dish, and it'll propagate itself. And so, I'm going to pass around a couple examples of Petri dishes that I have grown out. You guys can take a look. Okay, so you might be wondering what's in the Petri dish and where do I get them? Basically, it's a little bit of agar, which you use in a biology lab to grow out bacteria cultures, mushroom cultures. And you can buy this stuff online, or you can make it. In those mushroom cultivation books, it has different recipes for different types of agar for different strains, or you can buy it. I got mine from Fungi Perfecti, and this is just like a general agar medium that's good for many different types of mushrooms. So, here's some cool examples. This right here is a spore streak that I did. So with your spore print, you basically take some spores and rub them on the agar, and it doesn't take much at all. But this one I made into a heart shape. Or you can just do it, in a normal streak. Okay, so this one's a tissue culture, and this is just spores. Alright. And you have to be very careful when you're doing this that you don't contaminate the agar, because it's very easy to pick up other types of bacteria. So what you need is a clean room. Okay, so for a clean room, unless you have access to a laboratory with like a HEPA filter, you kind of have to be quick and clean about it. So the best way to do it is to get yourself, you guys, if you're really interested, you might want to write down what I'm saying, just because I'll tell you all the supplies that you need. You're going to want to get some Lysol, paper towels, a face mask, possibly gloves, or definitely alcohol, and either a scalpel or some kind of X-Acto knife. And so, to create a clean room, the easiest way that I've found, the easiest low-tech way without spending too much money, is to actually use your bathroom. So you want to clean your bathroom down using alcohol or a low bleach solution. And then what you do is you take a shower for like 10 minutes or whatever, and all of the steam will make all of the bacteria contaminants fall to the ground. So you're going to want all of your materials in there. You don't want to leave the bathroom once you take a shower. So it's also good to do it naked, because clothes are a huge contaminant. All right, so you get naked. You do your Petri dishes, and you get your spore streak or the clone that you want to make from the mycelium, and you either do spores or you do the tissue. I guess we should. Is anyone interested in how you make agar, or?
I just have a quick question. Okay, so when you're making spore prints, do you have to be worried about contamination?
Yes. You always have to be a little worried about contamination. Well, not necessarily. It's easy to use a clean piece of paper. There are actually surprisingly low contaminants on just like a white sheet of paper. So you get like a piece of notebook paper, open it up to a new page, and put the spores on top. but then you want to cover it with a glass, and then cover it with like either slip it into a plastic baggie, or put like an alcohol soaked paper towel over it or something like that, and then just let it set overnight. But after you take off the mushroom, you want to fold it up immediately and put it in a bag and store it away. The spores can live for like 20 to 50 years, or they can be viable for that long. So you can always take a spore print and save it for a long time, but you don't have to set up a whole cleaner to do that. All right. So, do you guys want me to go over how you make agar, or is it kind of okay? So you get this powder. This agar powder, and there's actually directions on it. It's fairly self-explanatory, but what you do is you take a level teaspoon of this, or 3 actually, and put it with 1 liter of water. And then what you want to do is, you need a pressure cooker, or this is an autoclave, so it's a little bit more specialized, but you don't necessarily need this, it's just easier. And you put it in here. You put it in a jar that's a little bit bigger than this, and you sterilize it for 45 minutes at 15 psi. And then you, and if you want to do it in a little bit lower tech of a way, you can actually just cook it on the stove in like a contained thing, but you have a much greater chance of contamination. So it really helps to get a pressure sterilizer. Another thing about this is it's not necessary if you're in an environment where it's easier to propagate mushrooms. You don't need all of this stuff, but in Colorado you kind of do. So you cook this for 45 minutes, let it set for 45 minutes, and then you pour it into your petri dishes. And you can buy these online at any science website, or take them from your local laboratories. They're really cheap and they're really easy to buy online. Okay, so you pour these, you want it to be about half full in the petri dishes. And then you basically just let these sit until they're cool, until they're completely room temperature. And then you can use them to either put your tissue sample or put your spores onto. Also, you can store these in the fridge for a really long time. Some of the cultures that I'm passing around to you guys have been sitting in my fridge for like a year, and they're starting to dry out a little bit, but they're still totally viable. So, okay, where are we here? All right. So the next step.
I just had a question. So the mushroom inside the petri dish, is that just keeping it at its like first stage of development?
Yeah, it's basically just starting to grow out mycelium, so it's making a mycelial mat. And it needs other environmental factors to start fruiting. Sometimes if it's like a really kind of robust mushroom, it will start fruiting from the petri dish, but usually not.
Okay.
You can also store any kind of mushroom that's growing out in the fridge for a long time.
And you're putting that mycelial mat inside the jar, inside the pressure cooker? No. So you basically, you want to make the agar, and then you pour it into the petri dish. Yeah.
And you can save these in your refrigerator. But you don't want to pressure cook the mycelium because you'll kill it.
Okay.
Yeah. Yep.
So when you're doing a clone, do you want to just cut directly into the mushroom, or do you just want to graze the top?
You basically want to make a square. So you want to bruise the mycelium as little as possible. So you're going to take your little scalpel, and you kind of just make like 4 little indents, and then try to pry it out.
Okay. So you want it to be like super thick, or just really thick?
You want it to be like a little chunk.
Okay.
Yeah. Cool. And also you don't want to place it just right on top of the agar, but you want to make it kind of slit, you know, place it inside. Okay. So, moving on. Next step from here, once the mycelium is fully grown out, you want to expand it even further. So you can start fruiting. So, the thing that I find that's best to expand it initially is rye berries. You can get these at Whole Foods. You kind of have to order them in bulk, but just give Whole Foods a call. So nice and rye. What's that? Oh yeah, vitamin cottage. That's another good place to get rye. Okay, so with the rye, you also want to sterilize it. You want to kill any bacteria or any fungus that might compete with it. So what you do is you take the rye, and there are, are you writing this down? You want me to give you the recipe right now? Okay. So you're going to do, basically you're going to do 1 cup of rye in this, and then you're going to fill it till it barely grazes the top of the rye, so you can barely see that there's water. You want it to be like a millimeter over the top of the rye. And that's the best way that I've found. There are actually recipes that are a little bit different, but this seems to make the rye the perfect kind of consistency after you cook it. So then what you're going to do is you take the lid of your jar, and this is the best size of jar to get. I think it's, how big are these? 1 quart. So you take a quart jar, and you want to have holes in the lid so there can be air exchange for the mycelium. So the best way to do this that I've found, you can either drill 3/4 inch diameter hole, or it's actually really easy to get a hole puncher and just punch 3 holes around the rim of the jar. But you don't want to leave it totally open because then contaminants can get in afterward. So what you do is you take a filter patch. You can either get these from Fungi Perfecti, or the low budget way is to just get some Tyvek from the post office. Tyvek. You're not really supposed to use it for anything other than shipping, but it is a really good material. You just go to the post office and it's like those plasticky kind of envelopes that are used for shipping, and they have, it's like a permeable membrane, but filters, this filters up to 3 microns, so I assume that that's similar. So anyway, you can either get these filter pouches online or you use the envelopes from the post office, and you put them under the lid that you punched holes in like this, and then you place it on top. Put them in your pressure cooker. Again, pressure cook for 45 minutes at 15 to 17 psi. And take them out. You want to shake it up, break up the grain. Helps kind of like hit it against your hand like this. And then just let them sit maybe overnight to make sure that they're completely cooled down, because you don't want to put the mycelium in when it's still hot. Alright, so the next step, excuse me.
About what temperature do you want to put the mycelium into the rye?
You want it to be room temperature. Yeah. Yeah, if it's a little bit warmer, they can handle it still, but it's best if it's completely room temperature. So you just let them sit out for like overnight and cool down.
So like 70 degrees?
Yeah, yeah. You don't have to be too precise about that one. Unless you're using a strain that's really tricky to grow. But you'll probably be starting with something a little bit easier. So I should try these. Okay, so the next.
In the pressure cooker, do you just put like an inch or 2 of water on the bottom? Is that what
Yeah, you put like a 1/2 inch of water. Your pressure cooker will probably come with specific instructions, but I think generally it's like 1/2 inch of water under the little tray thing. And then this one actually has, it's kind of like, I didn't bring it, but it's got a little, it's like a double boiler kind of. So there's another little insert that goes in here, and you put water and then the other bucket, and then put this in. Okay, so the next step to expand your mycelium is to take your fully grown out petri dish and you want to slice it up. This can make about 10 jars, 10 quart jars. So you'll slice it up into a pie, about 10 slices or so. Like so. Unless it's unevenly grown out. And this is actually really interesting because you can either choose to grow out all of your mycelium, or you can pick the most robust part of it to grow out, and you can keep kind of expanding on the really good-looking stuff. And so this is how they create really well-fruiting mushrooms and select for different qualities. So if you want to select for different, or for like the best fruiting mycelium, you're going to want to take the stuff that looks kind of like this, as opposed to like cottony, fluffy mycelium. You want the stuff that's branching outward rapidly. So generally I end up just using all of it, but if you really want to get into the biology of it, selecting for different better strains, then this is the way to do it. So again, you want to get into your clean, sterile room, probably naked, and it's funny because my roommates are always like commenting on how I'm like walking out of the bathroom with a towel and like with this thing. Like, what are you doing in there? Anyway, so you go into your clean room again. You slice this up into 10 sections. Take your little scalpel, and you just select a little piece and put it in here. And the best way to actually do this without contaminating the entire thing is to take a piece. You want to open the jar away from you. This one's sealed shut. You want to open the jar away from you like this and drop it in, and then quickly close it up again. And by doing it like this, you avoid like breathing over it or reaching around it and possibly dropping spores of something else or other bacteria in it. So then you close it up pretty quickly. Give it a good shake and set it out to grow. And depending on what you're growing, it likes different temperatures. The humidity is going to be pretty standard, about 80% or so, 60 to 90 really. Inside here, the rye will pretty much regulate that.
I'm just confused. How much rye do you put into the actual jar? Is that like how much rye you would put in, or is it just a cup?
No, this is actually expanded. You only put about a cup of
that's
rye.
Okay.
Yeah, 1 cup of rye, and then the water goes right, so you can see right over it.
Okay.
Millimeter over it. All right. So then you let it sit until it's fully colonized the rye. I actually have, I think I brought with me, oh yes, a really gross example of a contaminated one. So this one, some of them are going to get contaminated, some of them aren't. And I guess that's the benefit to having multiple jars, but this one is full of bacteria and disgustingness. If you want to look, mycelium is the white stuff, so it's kind of still competing, still fighting for its life, but it's probably not going to work out, and I'll end up composting it.
How can you tell it's contaminated?
You can tell it's contaminated because it looks gross, either slimy, green, anything but white and fluffy, really.
Does the humidity stay where you want it to be at in the jar, or do you have to adjust that yourself?
The humidity stays where you want it. If you don't get it right with the rye, you get chances of other stuff growing out. So it's kind of important that the condition is there. And that's for this oyster. Yep.
Now is a good time for it, but could you go over some of the types of contamination later?
Oh, sure. There's actually, it's really cool. This book has a a really great list of contaminants, so you can identify them, and it has like, if you're gonna look at them under a microscope, what they might look like, and how to identify. But the most common one, that's kind of an absurd one, you won't see that too often, but the most common one is a penicillium mold, just the green mold that grows in your kitchen on bread and stuff. And that's the most common one floating around, but it really could be anything, any other type of mold, bacteria. Once they're grown out, I had an issue with flies just recently, so yeah, there are tons of different contaminants. Basically anything that likes to eat the same stuff as mushrooms. All right. Okay, so you're gonna let your jars of grain grow out. And then you're going to expand to your final fruiting substrate. A substrate is something that mycelium likes to eat, so rye is a substrate, but then the fruiting substrate might be something different. And for the oyster mushroom, which is the white one that you guys tried, that looks like this. This is actually the one that is recommended for first-time growers because it's really easy to cultivate. It's really quick growing. The conditions can vary a little bit without it dying. And it's pretty robust, so it'll be propagated pretty easily, so you can kind of screw up a little bit and it'll still work out. So, oyster mushroom, oh, and the other thing about oyster mushrooms is that they grow on a variety of substrates. So, this is growing on wood chips right now, and this is a type of oyster mushroom. I've tried it on coffee grounds, just spent coffee grounds from a coffee shop that I went and picked up. You can mix, straw is a really good one, oat straw or wheat straw. But really you can experiment with a lot of stuff. And these oyster mushrooms are the type that actually will decompose the hydrocarbons as well. So this is kind of an amazing strain of mushroom.
Do the flavors, or can you tell the difference between the substrate and the taste of it?
That's a good question. I haven't really experimented with that. I'm sure you can. But I don't know for sure. So, yeah, I think the most common one is straw, just because they grow really well on that really quickly. But so that's what they'll use in like a commercial market. Like if you're buying them from the grocery store, they would probably grow on straw. But I haven't really been able to tell.
Do you use any specific type of wood in your chips?
Yeah, you do, and it depends on what strain you're growing. So generally speaking, you want to use a hardwood. Any hardwood will do, but oak and alder are really good ones. And those are kind of hard to find around here. But I did talk to this one arborist who was kind of telling me other different types. So if you want, I can email you afterward, but again, in that book, it tells you what different types of materials are best to use for which mushroom. For shiitake, it's almost exclusively oak, but for the oyster, they'll grow on anything. So, okay, where was I? All right, so back to this. Once the mushroom is fully colonized in the jar, it'll be white, fully white, and you want to give it a good shake. You don't want to let it get too colonized because then it'll turn into a hard brick and it's hard to like break up and spread elsewhere. It'll fully colonize, turn into white fluffy, and then what you want to do is take your other substrate that you're going to use, and you want to pasteurize that. And the way that you can do that, there are a couple different ways. The easiest and cheapest way is to, you can either use a hydrogen peroxide method, or you can dunk it in water for like 6 months. That takes a while. So the hydrogen peroxide method is you use you want a 3% hydrogen peroxide solution. So I believe that's 1 gallon of water to 1 liter of hydrogen peroxide solution. And you basically want to take whatever substrate you're using and let it sit overnight. submerged in the nitrogen peroxide solution. The other thing, the reason I was experimenting with spent coffee grounds is because they are actually sterilized in the espresso machine right before they're dumped into the thing, so they're pretty much sterile already. So in that case, you can just use them, and you don't even need to do the sterilization method. Question?
How did it turn out with the coffee grounds?
Well, it turned out pretty well in the beginning, but then I got a fly contamination issue. So they were basically to this stage of fruiting before there was a bit of contamination. And I think the next time around I wouldn't use 100% coffee grounds, but it was cool to see that it did work like that. I would probably mix it with straw. And there are actually a bunch of different formulas that have already been tested in that book. So I recommend that again. All right. So another method of pasteurization is to take your substrate, pour boiling water in it, mix it around, and then let it sit. You use one of those buckets that you can get from Home Depot, and pour boiling water in. You want it to be, depending on what you're growing, you want it to be a certain level of a certain moisture content. So you kind of have to measure that out, depending on what you're using. But you can do pour boiling water over it, let it sit with the lid on for a few hours until it's room temperature again, and then you mix the jar of grain with it. For this stuff, you don't need to use a clean room. By the time the mushrooms are fully colonized in a huge substrate, they're pretty bacterial resistant. They create enzymes that basically sit on the external parts of them that deter any other kind of parasitic mold or whatever. So you mix it in. You can either do the bag method, you can do the tray method, depending on what you're growing, and again, you just let it sit in its desired conditions. For oyster mushrooms, it'll take about a month to colonize straw or coffee grounds or whatever you're using, and then you want to have it enter the fruiting phase once it's fully colonized. So to initiate fruiting, by fruiting I mean when the actual mushrooms grow, you modify the environmental factors so it starts fruiting. And in nature, it would generally mushrooms come out when it starts raining and the temperature drops, and it reaches a certain point of humidity. But in your house, you can kind of mimic the natural environment by just watering it more, spraying like 3 times a day, and putting it in a cool area. Oh, and you also want to have like a little bit of dappled sunlight to mimic spring or fall or whenever it would naturally fruit. So it's kind of like a lot of information to take in. Do you guys have any questions or anything?
Could you explain the difference between how mushrooms grow in the wild and how they grow in your sanitary area?
Well, there's no real easy answer there. Basically, in the environment, they interact within the ecosystem. So with a lot of different types of mushrooms, they haven't even found out how you can cultivate them because there's such a dynamic interaction between the bacteria that exists and the other plants. And for example, chanterelles, if you guys have ever had them, they just discovered that it takes Douglas firs, 2 different types of bacteria, and then some other kind of tree. But basically, it's an interaction between 4 different species that makes them fruit. So it's a very complex kind of interaction. And so they've only found out how to cultivate a few different types of mushrooms even, and that's why you only see a few different types at the grocery store. And they've only even identified what they think is 10% of all of the fungi that exists in the world. So if you're interested in mushrooms, there's a lot to be discovered. And basically with this, it's a really controlled environment, and they found out what works for a couple different types of species. And by basically eliminating all of the other stuff that would compete with it, whereas in the environment, there's a kind of a dynamic thing happening.
If I decide to start growing my own mushrooms, can I use the pressure cooker that I already have, or do I have to buy a pressure cooker, make sure it's sanitized and dedicate that?
You could definitely use a pressure cooker you already
Really?
have. Yep.
Is there any difference in protocol, or do you just have to, have it cooking for longer, or any suggestions on that?
Well, with a standard pressure cooker, it still has a little gauge, right? That tells you.
They usually do.
It doesn't? No. Okay, so with that, it's a little bit trickier. You basically, with this, it's easy because you can tell what pressure it's reaching and for how long. For that one, I think it really just depends on what type you have, but basically what I would do is just pressure cook it for like 3 hours on high heat, because that's kind of what it takes. Well, maybe 2.
Let's try that.
Yeah, I mean, once you think it reaches maximum temperature, leave it on for 45 minutes. And that's the benefit to having one of these that has a gauge, but you don't need it necessarily.
So I think you can get like a week, and that'll keep it at a certain PSI and let it steam out. So you keep saying it like 15 or 17.
Yeah, usually like when you buy the pressure cooker, it'll say how fast PSI it goes up to.
Yeah.
Maximum, and then when it reaches
I bought mine a long time ago.
Alright, well, I have a question about temperature. Do you change the temperature at all, like when you're fruiting them?
To initiate fruiting, you want to lower the temperature and increase the humidity. Okay. So it also helps to have a low humidity and temperature gauge. Oh, here's mine. It's 36% humidity in here, 69.5 degrees. And these things are fairly cheap if you find them at like I can't consider it or whatever. And that helps.
What's that called?
This is called I think it's like a thermohygrometer, but I'm not 100% sure. I would just search for temperature and humidity gauge.
If you lower the temp, would it be like taking it from in your room where there's sunlight to your closet, or would it be like
It'd be like taking it to your cellar.
okay?
Yeah. Yeah, or in your closet. It depends on like what season it is, and it's basically taking it from like 70 degrees to like maybe 55.
Back to the Petri dish states, how is it getting new air? Because I thought those were pretty tight. Is there enough air there for it just to start off initially?
Yeah, there's enough air for it to start off. That's why you only want to fill it about halfway, because you want there to be enough space for the air, or for the mycelium to have air to grow. But you don't really need to open it up or anything like that. Especially here, it's so dry that you don't want to do that if it'll dry up. So.
Also, how long does the entire process take?
It depends on what you're growing. Oyster mushrooms are fairly quick. So from start to finish, if you're on top of it, it'll probably take you maybe a month and a half. But for shiitake, maybe 2 months. And then some of them will take, 6 months or more. And then some of them will take 1 month. It kind of depends on the stream.
How long are these supposed to be exposed to the sun?
That's a good question. Generally, you want like a 12-hour cycle, just like a daytime type thing. It was recommended to me to put it in my kitchen where there's kind of like dappled sunlight, because you don't want them to be in the direct heat of the sun, but you do want there to be like a little natural light.
Is that for all strains or just for oyster?
Well, I think generally it's for everything that I've grown, you do need a little bit of sunlight to initiate fruiting. There could be something where it requires less, but I'm not sure about that.
Just like it's heat lamp.
You don't want to use a heat lamp because that would dry out the region, but if you're growing something like in your closet, a regular light bulb would probably do it, or like one of those sunlight bulbs. Yeah.
I don't know if you already went over this or if you're gonna go over it, but what are some of the other uses for mushrooms besides just to cook to eat?
Well, I kind of touched on it a little bit. Oh, easy, perfect. Primarily, the two other things that mushrooms are used for these days, and there's a whole variety of uses, but human health is becoming a huge one. Supplements with mushrooms are becoming really popular, and they're doing a lot of research about how they can influence your immune system with other diseases and so forth. And then the other one is microradiation, and I think it would be a good time for Lindsay to start talking about the project that she's been involved with. Do you guys have any other questions for me?
Yeah, where do you get those bags?
Well, you can either, the two places that I've gotten bags are Hazel's mushrooms, which is a local mushroom growing facility. It's in Fort Collins. Or I'm sure you can get them online. You can get anything online. Or Fungi Perfecti. And those are actually great because they have a little filter patch. So there's a little bit of air exchange, which is really good for to help initiate fruiting and keep the contaminants out, and you can still have it sealed.
And so when you're taking from the first, when it's just with the rye, and then putting it in the second substrate, do you put everything in the bag? Okay, and then you just like shake it
Yep,
up?
shake it up. Yes.
When you're fruiting, how worried do you have to be about contaminants from the air?
Wait, when you're fruiting, what was it?
The mushrooms, like, for example, like you have your setup right there in the fish tank, like, do you have to worry about contaminants coming from the air?
You do, yeah, and for these ones especially, because this is the second time around for fruiting. But, I mean, you want to leave it in an area that's not, you don't want to be like throwing around the compost in the same region. But by this time, they're pretty resilient. They produce antibiotics and stuff like that, other antifungal enzymes.
So would you usually have like a cover on that of some sort, or?
Well, these were in a bag, and I took them off so they could get more air. And then I let them sit for a really long time, which I probably should have done. I should have let them sit for like a week, and then started fruiting again, initiate fruiting again. But I've just been leaving these in my room with a little bit with a fan nearby, so they get a little bit of air, and then I've been spraying them. So I haven't really been worrying about contamination. But for some strains, you might want to put them in an enclosed type of structure.
How many times can it fruit for?
It depends on how much substrate you have. Something like this, and especially with hardwood, there's a lot of substance there. So these can fruit like up to 5 times maybe. For me, I've had success with 3. But it really depends on like what your substrate is, what your strain is, how big your fruitings are the first time. And so like, as you can see, this one is a lot smaller because it's fruited a couple more times than this one has. So every time it shrinks because more of the stuff is put out of the mushrooms.
What are those things in the fish tank? Like
These are shiitake blocks.
blocks.
Yeah, like what you have.
Right, but how do you make that or get that?
Well, it kind of just turns into a block form when it's in the bag. It basically holds all the stuff together with mycelium. And then I took the bag off and they just stay in this form.
Just take it out when it looks totally colonized?
What you want to do, another environmental factor that I may have forgotten to mention is that you want increased airflow. So you want to increase the airflow, decrease the temperature, increase the humidity, have a little bit of light to initiate fruiting.
Okay, so
you take it out of the bag?
It kind of depends, but I wouldn't recommend fully taking it out of the bag just because it's so dry here. If we were like in California or something, taking it out of the bag would be great, but here it's like, it's pretty tricky. You need to maintain a higher level of humidity.
Okay.
So
it will fruit in the bag?
Yep. As you can see, this one's trying to fruit in the bag. I want to take a clone of the tissue before I let it fully escape this environment. Just because this is a strain that someone gave me, so I don't have it on reserve, so I'm going to preserve it by putting it in the petri dishes. But yeah, they'll start fruiting in the bag, and then you'll know to do all of those things.
When you're starting the petri dish, you don't have to worry about being in a cleaner?
You do.
You do?
Well, yeah, you want to pour the petri dish in a clean room, you want to make the transfer in a clean room, and then you want to make the transfer again from the petri to this in a clean room.
And then there's only stages you have to be in.
Yep.
How do you know when to harvest mushrooms?
That's a good question. Basically, you want to harvest, they taste best before they release all of their spores. And then after they release all their spores, they're going to start to decompose and go back into the ground or whatever. So once they look kind of like this, but before their top is flattened out, that's when you want to harvest them.
Yeah, you were talking about like medicinal uses of mushrooms. Like elaborate, like what can you use?
Well, there's so many different uses, and I would recommend looking at this book. This talk isn't really focused on that, but there's a really good little chart that I can show you in this book that has just a bunch of different strains and then what they found, like, for example, anti-tumor properties, increased kidney function, increased liver function. Let me find this, and I can show it to you. Or you can just come down and look afterward. Oh, here we go. Stress reducer, sexual potentiator, nerve tonic, lungs, respiratory, liver tonic, kidney tonic, immune enhancer, cholesterol reducer, cardiovascular, blood sugar moderator, blood pressure, antiviral, anti-tumor, antioxidant, anti-inflammatory, anti-candida, antibacterial.
Is that all from eating?
Eating freeze-dried. So like in a concentration.
Okay.
All right, well, I think now's a good time to move on to talk about another thing that mushrooms can be used for that's really amazing, microremediation, and this is Lindsay, and she was involved in a really amazing project. It's kind of bad.
Have you heard of the lawsuit in Ecuador?
Yeah.
Against Chevron? The lawsuit in Ecuador against Chevron Texaco? It's been going on for a really long time. It first went into courts in the early 90s in New York because Chevron, our Chevron Texaco based in Texas, United States, operated in Ecuador from the late 50s until the mid-70s. And during that time, when they were extracting oil from the Ecuadorian Amazon, there is a certain percentage of the oil that's too difficult to refine. So the standard is to re-inject that percentage back into the ground where it came from. But Chevron didn't do that, so they just left it in these big pits. This is a photograph that I took in 2006 of one of the pits, and there's about 600 estimated in this quite small area. I think Ecuador is only the size of Colorado. This is only like a very small part of Ecuador, so it's highly concentrated. And so they've estimated that there's 18 billion gallons of toxic crude waste sitting in pits there. And that's what Chevron's on trial for a second time now in courts in Ecuador. There's about 20,000 plaintiffs in Ecuador fighting the company. And we'll see how that turns out. Apparently, there's a Boulder Corporation involved as well now because they were contracted by Chevron.
Yeah, they were being contracted as like environmental consulting groups, and now Chevron is trying to like countersue them to try to get some money to them, saying that they're responsible.
Yeah, the lawsuit's really interesting. Are there any law students in this room? Oh, cool. Yeah.
Just to interject, I heard about that this morning on the news.
For the first time.
Yeah, I think they just like today or yesterday they were once again made accountable for taking care of all the legal costs and stuff. Of course, they're going to contest it again, but.
Well, yeah, yesterday morning they agreed, well, they didn't agree, but Chevron was due to pay $9 billion to Ecuador, but both sides want to appeal because Chevron says that the science that they used was faulty and that it was biased and that the Ecuadorian government had paid off these scientists to give false information and that they don't want to pay that much, they think it's too much. And then, of course, on Ecuador's side, they're saying that that's not even enough. And so both sides are going to appeal again. But they did reach, for right now, a temporary kind of agreement on $9 billion to give to Ecuador.
Interesting. No, that's great. Yeah, it's really good to hear that people are keeping up with this. Especially for the lawsuits in the room, this will set a precedent for around the globe because there's never been a company in foreign courts treated for a case of this magnitude. So it'll be really interesting how it turns out. And so what happened was in the first lawsuit, Chevron Texaco was told they had to clean up 1% of the pools. There's kind of a governmental trade-off, which is why it was only 1%. But what they did was they dumped dirt over a lot of the pools. So when I visited people's homes, they would take me in their backyards and stick a stick into like a seemingly good-looking yard, and then pull a stick out of the ground and be covered in toxic crude oil waste. Or if it was heavy rains, it would start to leak out of the subsurface of the property. So part of what Kate and I are trying to do with this group called Amazon Micro Renewal Project, which is a nonprofit, we've teamed up to use oyster mushrooms to try to break down the oil waste. And the way that it works is you feed the oil a substrate, so we're experimenting with bamboo and wood and different things like that. We actually got to reuse a waste from a broomstick making factory, and we got to use all their shavings to use that as our substrate, which is really cool. It was just down the street from where we were working. I just wanted to point out, it says, "Welcome to the petroleum and Amazonian capital." This woman was very happy to be there, as well as this woman who seems very happy about the oil. So I'm a cultural anthropology student. I'm on an MA program here, so this is really confined with my work. And so part of what makes me really interested about microremediation is how it can give people a really quick solution where they don't need to wait for a government or a lawsuit to do the cleanup for them. It just gives us all agency immediately to transform our environments, or in many people's cases, their backyards. These are just some photos from the sites that I was working at. This is the mycelium that we're using, again from oyster mushrooms. Just spreading around and feeding it the substrate. And as it digests the substrate, it also digests the oil waste as though that is a food for it too. So it breaks it down to make it neutral. What it cannot do is break down heavy metals, so those need to be treated differently.
So if we use that to clean up our backyards or whatever, could we still eat the fruits that it produced?
No. But what's great about it is, like in most remediation, any remediation specialists in here are studying it. At least I know bioremediation and certain other, like really high intensity remediation places. There's always like a certain percentage that just gets dumped into landfills because they don't know what to do with it. So the beauty of using mushrooms is that one is contained, and two, there's also a lot of work being done of planting it in direct proportion under trees that can then filter out and kind of decompose it as the whole system's remediation.
Are there any hygienic liabilities to having a bunch of mushrooms growing in your backyard that are sucking up oil? Is there anything that could possibly a bunch of fungus growing be kind of bad for your living?
Well, if you have something about growing oyster mushrooms and growing them indoors is that sometimes for some people they can irritate lungs if they release spores, that is. And so that's why it's always helpful to have a HEPA filter. Outside, generally they're pretty widely dispersed just because of the wind. So I don't, unless you're specifically allergic, which I haven't heard of anyone being, but it's totally possible that someone could be. I don't think there would be any other complications.
Are oyster mushrooms something that would naturally grow there, or are they just being introduced into the environment to the oil?
That's what we've been experimenting with, trying to find local strains in Ecuador. The thing is, no one's really experimented in this biome before, which is another reason why this research is really important to the lawsuit, because what happens in the lawsuit is they have to decide how they're going to do the cleanup and how much it will cost. So you need to know what kind of techniques you're using. But since no one has ever used microremediation in the Amazonian biosphere, we don't even know if it technically works, although I've seen it qualitatively, and I'll show you some photographs of it. But part of that is trying different strains and seeing which ones work and which ones don't, and which ones could be a problem. And we don't want to use oyster mushrooms because we're worried that people are like, oh, those are edible, and eat them, and we don't want that to get confused. So we're trying to find a strain that is not an edible variety.
Generally, with microremediation, it is advised to go looking for a local strain and then select for something that will break down whatever you're trying to break down. So that's the process that's usually used. Is people are hunting, they take something, they clone it in a petri dish, and go through that whole process.
Alright, so I was actually reading about this around the whole oil spill, but what's your argument against the worry that an alien species of mushroom or whatever is going to be something that colonizes so quickly and spreads? Like, a lot of people have ecological worries about that.
That's a good question. There's always a concern about introducing new species to a new area and having it become invasive because there have been so many issues with that in the past. So that's why that technique of hunting for a local strain and then cloning it and using that is a better option. But at the same time, it's kind of like, I don't know, you're just weighing cost and benefit type of analysis for an oil spill that's so huge and so pervasive and destroying the ecosystem as it is. It's better to use something that works or experiment something new or what.
What happens when the animals eat contaminated mushrooms? Is it better than just having oil spills in the backyard anyway, or is there a threat?
The thing is that the mushrooms aren't really actually going to fruit for the most part. Like, we're just putting mycelium in there to break it down. They're probably not going to really be fruiting. Have you seen any of that?
I have seen fruiting on piles of remediation.
I just haven't seen it down there.
Yeah.
I guess
It depends on the project. I mean, whether they fruit or not, a lot of times they'll break it down either way. With heavy metals, it's good if they fruit because you can actually harvest the mushroom, and then there's a new market where you can like sell it to like a metal factory, and they'll take the mushroom and break it down and resell the metal. So it's kind of interesting.
Oh yeah, this is a picture of mycelium growth in Oregon. It's the largest organism in the world. What is it, like anyone know the number? 200,000 square feet, I think it is.
There's only like one cell on that thick, but it covers like most of Oregon.
It really makes it okay. These are our projects. And as you can see in the landscape, that even though Chevron stopped drilling in these areas almost 20 years ago, it's still everywhere. Like just on the leaves, because you get acid rain and runoff, and that's why it becomes so pervasive. So what we're trying to do is block it off as soon as, block everything off as soon as we can, so that it doesn't go into all the Amazonian waterways and infect the whole area. Can you imagine how widespread that is? So what we're doing, testing which strains work best, we're doing soil samples, doing different percentages, using different strains to see which work best, and hopefully being able to think ahead of which won't be invasive and which will be good. And that's our substrate from the root surface factory. Taking records of what plants are growing there in the oil. It's pretty cool to see that stuff still grows. This is an experiment we tried. I know it looks really weird. No one's ever done this before. Usually with microremediation, you layer it horizontally, like you would put the mycelium, the soil, and the substrate, and have it be in layers that way. But for us, for such a huge space, we wouldn't really be able to make those layers. these pools go down like 15 feet deep and perhaps more. So we're trying to do vertical layers to see if that works, like do mycelium, soil, substrate, etc. When I went back, I got to visit a year later after we had our two piles, one that was treated with mycelium and one that wasn't. And it was so exciting because there were bugs and ants living in the remediated soil of mycelium, and the one that didn't have the mycelium, it's still like you could smell and see the oil in the soil. So it's just so empowering to see how much it can transform our environments, especially for something such a huge scale. This is like so depressing, but actually doesn't have to be because we have the power to change it. We don't need to wait. So, yeah, it's the future. Yeah.
How long would it take for the mushrooms to break down the oil? There's so much, it takes years and years and years.
Not technically. Well, we have, for that one site, it took a year for the pile that it was. So it would depend on how much space you have on what you're breaking down and how much mycelium you have.
But for the oils 15 feet deep, that would take just
right, so
years just to break down.
we're not saying that this is to replace bioremediation. We think it should go in conjunction. Also, a lot of times with bioremediation, this is widespread. This is all over the Amazon. So if you're cleaning out that pit, there's still all the surrounding soils needing to be remediated. And for me, what it does is it addresses people who have just a little bit in their backyard that they can clean up right away and not have to wait for the government to do it. And on top of that, what we're doing is installing rainwater harvest tanks with mycelial filters. That way they're able to get clean water that isn't acid rain right away. So it's pretty cool.
How did those mushrooms incorporate into the green group structures?
Oh no, this is just my vision of the future.
It's actually a really good idea, though, to put mycelium on a green roof because they filter so many different things, other bacteria, E. coli, whatever. And also, a lot of plants could reach their full potential without partnering with mycelium in the soil because they basically filter nutrients from the soil to the plant roots, depending on what strain we're talking about.
The other thing is that we have a bioremediation specialist on our team, and he was explaining to me how when you bring mycelium in first, it attracts all these other organisms to come in and start breaking it down as well. So it just, from the beginning, is a more interactive remediation, having only bioremediation. Because it actually brings in the bacteria and other things.
So those poles, you treated, you inoculated the poles and then you stuck them down in the dirt? Or in the muck?
Yeah, basically. We took, we made like all these little, we called them burritos actually. We had like cardboard, which is also a substrate that you could break down, and the straw and the bamboo, and just sandwiched it into the ground, and then just threw a lot of substrate. And the bamboo that was up there is also substrate for the Eaton. And
how does it go down?
What?
How does it go? How did you get 15 feet down?
We didn't go that deep. What will happen is as it rains, it will percolate down.
Okay.
What is the byproduct of the breakdown process? Does the mycelium consume the hydrocarbons, or?
It does. They're really similar to cellulose, which is like kind of a complex hydrocarbon. So I think essentially they use oxalic acid, and I don't know the exact interaction, but I've been meaning to look into it. And they basically take the hydrocarbons and break them down. And
Does it feed off of the hydrocarbons? Okay.
yeah, and that's another question. There might, it might not be entirely 100% broken down, but definitely a really good start.
Yeah.
The last thing that I would say to you about all this is we created a mycelial lens because basically mycelium, I don't know if you touched on this before it came in, but you could look at it as immortal in a certain respect because you keep giving it humidity and the right temperature and substrate, it can continue indefinitely, at least with what we're doing. So what you can do is you have this huge pile of the mycelium and the substrate, and you take a piece off of that and you bring it someplace else, and You don't have to put money into that because it's free and you'll keep reproducing and stuff. So what we're trying to do is like keep this library of spawn and keep giving.
Once you have like, so where you had a big pool of oil, then you have a big mycelial mass. What do you do with the mycelial mass, or are you just going to have like fields of mushrooms? Well, it kind of depends on the project that you're doing. Here, let me go back a couple slides. For this one that Lindsay did specifically, I'm not sure what they plan on doing with them. But in other projects that I've seen before, specifically this one that was used, they took burlap sacks, stuffed them with mycelium and wood chips, and then created a little dam where there was agricultural waste coming down, E. coli, and the mushrooms filtered the water. Here's a little display. So those are the sacks made into bunker spawn, placed in where there's agricultural runoff or contaminants. It filters the water and the water downstream, goes back into the ecosystem, and then these are removed from the area once it's fully cleaned up, and then they fruit elsewhere, and then you probably compost them. Sometimes they have to go to landfill because they're full of contaminants, but in the case of E. coli, they just go to bacteria, and so just compost and go back to the earth.
So does this, fungi or whatever, does it like keep on consuming things that it's growing off of, or is there a point where it just stops and something?
You would have to give it a substrate.
Yeah, if
Right.
there's nothing around for it to eat, it'll just die. But if you keep it in the right environmental conditions with the right food, it'll keep going.
I mean, it's not something to be terrified about. Because like, if you're a gardener, you'll see mycelium as you're gardening. It's just like it's everywhere for the most part.
Yeah, I mean, there could also be like other competitors from the environment, like other mycelium that's local and stronger or whatever, and that'll take over.
But it won't ever like put the oil back. It's always going to keep it to its.
Well, it basically breaks down the oil, the molecular structure of the oil, and turns it into mycelium. So, yeah. With heavy metals, it does just hold the heavy metals, and then it'll go back. And that's why you want to harvest it if there are heavy metal contaminants.
So the heavy metal contaminants come up into the top of the fruit.
Into the fruit body, yeah.
Can you talk about the living water?
So, yeah, that's why you probably, if you're mushroom hunting, and you're in an area near some industrial something or other, it's probably wise not to eat the mushrooms. You know what they are, and you know that they're edible. They can definitely become heavy metals in them.
Going back to some of the benefits of mushrooms, the bioremediation is great, I love it. Going back to me shopping for mushrooms at the supermarket versus me growing my own. Now, besides the intrinsic benefit of mushrooms, like the nutrients that are inside, is it like something that it's very beneficial for your health if you grow your own, as opposed to buying a supermarket, as opposed to buying like say organic mushrooms? Like where's the difference with that?
Well, a lot of mushrooms that you find in the supermarket are grown in China, and there are a lot of heavy metals in China. And basically you can't, they might even call them organic, but if they're from China, the standards over there are a little bit sketchy. So you could be poisoning yourself if you're eating ones that aren't organic. Organic. Or do you have questions about like?
Do they use like a lot of pesticides when they're growing mushrooms?
Yeah, they could use pesticides. I think the heavy metal contamination is like the primary. I don't know. Pesticides are also not so great. So don't buy mushrooms from China. Try to buy organic ones. If you grow your own, you know what you're growing them on. You can also experiment with different things.
Probably save you a lot of money.
Possibly.
Yeah, that's
It's-
true.
Yeah,
I mean, there's a
if
lot.
you get it down, yeah. I mean, it can be tricky. I don't know, it's kind of like, it's just like either growing your own veggies in your garden or buying them from the supermarket. It's basically the same kind of cost benefit thing, other than the fact that there are other different applications.
Would you recommend buying them from a source locally, or is there any place around that?
Hazel Dental Mushrooms is the only local mushroom garden facility I know of, but they're great. They have a really good selection and they're all organic, so.
Hazel Dell. I mean, how do you spell that?
Hazel space DELL. And that's where these ones are from, and you can actually get them at Whole Foods. So.
And the farmer's market.
And the farmer's market. Yeah, there's an awesome huge mushroom stand at the farmer's market.
I was curious with the myco-remediation project, did you get involved with that through CU?
No, I was doing field work as an anthropologist down in Ecuador, looking at the lawsuit and interviewing people about their experiences. And then I started learning about permaculture, and I got my permaculture certificate, and I thought, why don't we just use microremediation here? It's perfect. And then I found out there was a nonprofit that was already doing it, so I teamed up with them. And yeah, now it's a big part of my graduate work here at CU.
Do you cultivate your own mushrooms outdoors?
Well, that was actually the other topic that I was thinking about touching on. In Colorado, it's really tricky unless your backyard is like perfect and you have like a perfect little microclimate with like trees and moisture and shade, partial shade.
So like if you had a ditch running through
Basically,
your
it's
back?
really hard here because it's so sunny and dry. We're in a desert pretty much. So you will see mushrooms coming up sometimes, but you can do it outside, and it's really easy and it's really inexpensive. I can talk to you about it afterward if you want, but here it's a lot more difficult than if you were somewhere with no rain.
Back to micro-remediation, did you say that you could remediate nitrates with this?
Yeah. Let me see here. There's actually a lot about it. Well, there's a lot of research that's been done on different chemicals and different strains of mushrooms. But if you want to take a look at this book afterward,
There's a nice chart in there.
yeah, there's a really nice chart. You might have to look. So many contaminants can be broken down by mushrooms, and nitrates are one of them.
This one I'm kind of getting at is it has more implications than just Exxon's problems in Ecuador.
Yeah. Yeah, I mean, E. coli is another thing that can be broken down.
Well, you know
Phosphates.
from Pennsylvania, the damage being done to the Susquehanna River Basin and from farm runoff, and it's primarily a huge nitrate problem. I'm just wondering, do you ever see this being something that can be applied commercially?
I do, yeah. In fact, I think that's where I want to head in the future. For doing more stuff like this. I know that there are a couple of hiccups because people have different patents on different strains and different processes, but I think it's something that's going to just, grow in the future.
Wasn't there that great case study in the Hudson area of New York where they cleaned up dioxin for using mushrooms? I think it's in that book.
Yeah, I'm not sure about that specific study. But I know the dioxins are one of the things that are on the list.
Have they tried mushrooms for cleaning up zero waste at all? There's a discussion of it, but
Yeah, actually there have been, and they found that that it works, but then the mushrooms are like extremely toxic, and then you have problems getting
So
rid
is
of
it
the
just like
mushrooms.
it's transfer basically?
Yeah.
So it doesn't really break it down at all? Or
Yeah, I think that's the issue. But you should definitely look at this. If you guys are interested in microremediation at all, this is a really good book. And actually, it gives a fantastic overview of the cultivation as well. So I would also recommend this one.
And anyone who wants to come down to Ecuador, I'll put our website up here.
Yeah, if you want to write down, if you're interested in cultivating and you think you might have questions in the future, feel free to write down my contact info. I can give you my email address. Maybe I'll write it down too.
We can't actually read that.
Yours is fine, her email address.
It's just really light.
Let me finish.
It says Amazon microrenewalproject.org.
I'll try this one.
Do you want me to read that so you can spell it?
I think she's got it.
Is that better?
Yeah.
Yeah.
Is that